Galileo Galilei, born in Italy in 1564, became a pivotal figure in the scientific revolution. He made groundbreaking discoveries in astronomy, physics, and mathematics. Galileo developed new instruments, like the telescope, to study the cosmos. His experiments with motion laid the foundation for modern physics. Galileo's support for the heliocentric model brought him into conflict with the Catholic Church. Despite these challenges, his impact on our understanding of the universe remains immeasurable. Before Galileo, our understanding of the cosmos was limited by what we could see with the naked eye. The telescope revolutionized astronomy. Galileo improved its design and used it to observe the heavens. His telescopes allowed him to see farther and with greater clarity. He meticulously documented his observations. His drawings provided evidence that challenged long-held beliefs. These observations constituted a paradigm shift. They contradicted the ancient Greek model of the cosmos. Galileo's telescope symbolized the power of observation. His work ushered in a new era of astronomy. Galileo's telescope revealed that the moon, once thought to be a perfectly smooth celestial sphere, was in fact a world with mountains, valleys, and craters. His detailed sketches of the lunar surface challenged the prevailing Aristotelian view, which held that celestial bodies were perfect and unchanging. Galileo observed the terminator, the line separating the illuminated and dark portions of the moon. He noted that the terminator appeared jagged, indicating the presence of mountains and valleys that cast long shadows across the lunar landscape. He even estimated the height of some of these mountains by measuring the length of their shadows. These observations were revolutionary. They provided concrete evidence that the heavens were not the unchanging, perfect realm described by Aristotle and accepted for centuries. The moon, Galileo showed, was a world with its own dynamic geology, not unlike the Earth. This discovery had profound implications for our understanding of the universe. It chipped away at the artificial division between the earthly and the celestial, suggesting that the same physical laws might govern both realms. It also fueled the imagination, planting the seed for future generations who would dream of exploring this newly revealed world. One of Galileo's most impactful discoveries was the observation of 4 celestial bodies orbiting Jupiter. These objects, now known as the Galilean moons, Io, Europa, Ganymede, and Callisto, provided the first direct evidence that not everything in the universe revolved around the Earth. Night after night, Galileo meticulously tracked the positions of these objects. He observed that they moved in predictable patterns, changing their positions relative to Jupiter over time. This led him to the inescapable conclusion that these were not stars, but moons locked in orbit around the giant planet. This discovery dealt a significant blow to the geocentric model of the universe, which placed the Earth at the center. The prevailing view at the time was that all celestial bodies orbited the Earth. Galileo's observations of Jupiter's moons provided clear evidence to the contrary. The discovery of the Galilean moons had a profound impact on our understanding of the solar system and our place within it. It demonstrated that celestial bodies could orbit objects other than the Earth, providing support for the Copernican heliocentric model, which placed the Sun at the center of the solar system. Section 5. Venus Unveiled, Phases and Cosmic Perspectives. Galileo's observations of Venus provided further evidence against the geocentric model. He observed that Venus, like the Moon, went through phases appearing as a crescent, a full disk, and everything in between. This discovery posed a significant problem for the geocentric model, which predicted that Venus would always appear as a crescent. The heliocentric model, however, explained these phases perfectly. According to this model, Venus's phases are a result of its orbit around the Sun and our changing perspective from Earth. When Venus is between the Earth and the Sun, we see its unlit side, resulting in a new Venus phase. As Venus moves in its orbit, more of its illuminated side becomes visible, leading to the crescent, gibbous, and eventually full phases. This elegant explanation of Venus's phases provided compelling evidence in favor of the heliocentric model. It demonstrated the predictive power of a sun-centered system, and further eroded the credibility of the Earth-centered view. Section 6. The Sun's Secrets, Imperfections in the Heavens. Galileo's observations were not limited to the Moon and planets. He also made groundbreaking discoveries about the Sun. Using his telescope, he observed sunspots, dark blemishes on the sun's surface that moved across its disk over time. These observations challenged the prevailing belief that the sun was a perfect, unchanging celestial body. The existence of sunspots suggested that the sun was, in fact, a dynamic and evolving object. By tracking the movement of these sunspots, Galileo was able to determine the sun's rotation period, the time it takes for the sun to complete one rotation on its axis. He estimated this period to be about 28 days, remarkably close to the modern value. Galileo's observations of sunspots had far-reaching implications. They provided further evidence against the Aristotelian view of the heavens as perfect and unchanging. They also hinted at the sun's immense power and the dynamic nature of our solar system. Section 7, The Language of Motion, Galileo's Physics. Galileo's contributions to science extended beyond astronomy. He pioneered the study of motion, challenging long-held beliefs. One famous experiment involved rolling balls down inclined planes. He measured the time for balls of different masses to roll down planes. This led to the law of falling bodies, stating objects fall at the same rate. This contradicted Aristotle's view that heavier objects fall faster. Galileo's work laid the foundation for Newton's laws of motion. Section 8. A Moving Earth, Challenging Ancient Beliefs. Galileo was a staunch advocate for the heliocentric model of the solar system, proposed by Nicolaus Copernicus, which placed the sun at the center, with the Earth and other planets orbiting around it. This model challenged the long-held geocentric view championed by Aristotle and Ptolemy, which placed the Earth at the center of the universe. Galileo's support for the heliocentric model was based on his astronomical observations and his understanding of motion. He argued that his observations of Venus's phases, Jupiter's moons, and the sun's rotation could only be explained if the Earth revolved around the sun. His advocacy for the heliocentric model was not without its challenges. The geocentric view was deeply entrenched, supported by both religious dogma and centuries of tradition. Challenging this view was seen as heresy, and Galileo's outspoken support for Copernicus's ideas brought him into direct conflict with the Catholic Church. Section 9. The Church and the Cosmos. A clash of ideas. Galileo's support for the heliocentric model brought him into direct conflict with the Catholic Church. The Church at the time held considerable power and influence, and its teachings were deeply intertwined with the prevailing geocentric view of the universe. The Church considered the heliocentric model to be heretical, as it contradicted the literal interpretation of certain biblical passages that seemed to suggest the Earth's central position. Moreover, the Church viewed the heliocentric model as a threat to its authority, as it challenged the Church's role as the arbiter of knowledge. The conflict between Galileo and the Church was not merely a scientific debate, it was a clash of worldviews. On one side was the Church, upholding tradition and religious dogma. On the other side was Galileo, championing a new way of understanding the universe based on observation, experimentation, and mathematical reasoning. Section 10. The Trial of Galileo, Science on the Stand. In 1633, Galileo was summoned to Rome to stand trial before the Inquisition, the Church's judicial body responsible for rooting out heresy. The charges against him centered on his book, Dialogue Concerning the Two Chief World Systems, in which he presented arguments in favor of both the geocentric and heliocentric models, though the book clearly favored the latter. The trial of Galileo was a landmark event in the history of science and religion. It pitted the authority of the Church against the emerging power of scientific inquiry. Galileo, despite mounting pressure, refused to recant his belief in the heliocentric model. Facing the threat of torture and imprisonment, Galileo was forced to choose between his scientific convictions and his personal freedom. Ultimately, he chose the latter. He recanted his views, publicly stating that the Earth was the center of the universe and was sentenced to house arrest for the remainder of his life. Section 11. Galileo's Enduring Legacy, The Power of Observation. Despite his persecution, Galileo's legacy lived on. His groundbreaking discoveries, his rigorous experimental methods, and his unwavering belief in the power of observation helped to usher in a new era of scientific inquiry. Galileo's work inspired generations of scientists to look beyond established dogma and to trust the evidence of their own eyes and experiments. He showed that the universe is best understood not through blind faith or ancient authority, but through careful observation, rigorous experimentation, and logical deduction. His legacy extends far beyond the realm of science. Galileo's courage to challenge authority, his unwavering commitment to truth, and his willingness to stand up for his beliefs, even in the face of persecution, continue to inspire people from all walks of life. Section 12. The birth of modern science. Galileo's enduring impact. Galileo's contributions to science were nothing short of revolutionary. He is often referred to as the father of modern science for his pioneering work in astronomy, physics, and the scientific method. His work laid the foundation for modern physics, revolutionized our understanding of the solar system, and helped to usher in the scientific revolution. Galileo's emphasis on observation, experimentation, and mathematical reasoning transformed the way science was conducted. He showed that the universe could be understood through careful observation and logical deduction, and that scientific theories should be based on empirical evidence, not just philosophical speculation. His discoveries challenged long-held beliefs about the universe and our place within it. By providing evidence for the heliocentric model, he helped to shift the focus of the cosmos from the Earth to the Sun, forever changing our understanding of our place in the universe. Section 13. Conclusion. The legacy of a rebellious genius. Galileo Galilei, a rebellious genius born into a world clinging to ancient beliefs, dared to challenge the very foundations of knowledge. Through his relentless pursuit of truth, his groundbreaking discoveries, and his unwavering belief in the power of observation, he ignited a revolution in scientific thought that continues to illuminate our understanding of the universe. Galileo's legacy is not merely confined to textbooks or scientific journals. It lives on in the spirit of inquiry that drives us to explore the unknown, to question what we think we know, and to never stop seeking answers to the universe's most perplexing mysteries. His story is a timeless reminder that the pursuit of knowledge requires courage, perseverance, and an unyielding commitment to truth, even when that truth challenges the status quo or threatens the established order. Galileo's legacy is a testament to the power of human curiosity and the enduring quest to unravel the mysteries of the cosmos.